And 243, I try to keep mostly descriptive, not inferential. We hint in 243 at inferential at the very end with the central limit theorem, but I try to keep this stuff at 244. Yeah. Cool so far? Okay, so here's what Mars, the manufacturer of M&Ms, tells me we should have. We should have 13% brown and 13% red. We should have 14% yellow, 24% blue, 16% green, 20% orange. Now, those percentages are so tight in some cases that it's almost ridiculous. I mean, to differentiate between 14 and 13%. With a sample size that's incredibly large, you can differentiate between them. We're going to have probably somewhere in the neighborhood of a few thousand candies, I think, to test. But honestly, it probably won't show any differences, but we'll see. We'll see. 24 versus 13, that's getting far enough away. For a while, actually, M&Ms used to say you should have 10% green, blue, and orange. You should have 20% yellow, red, and 30% brown. And that changed to this weird percentage of 16 and 14 and 24 and so forth and so on. So what I want to see is I want to see if this holds or if the alternative is going to hold. And what's the alternative going to be, friends? What's the opposite of this? Which ones? Careful. At least one of them. Now, this is the same as the randomness thing. This is the same. It might be that the blues are off from 24, but the rest of them are close enough. It might be that the browns and reds are off, but the rest are close enough. It might be, Will, that they're all off. Yes. It could be that every single one of them is off, but it doesn't have to be all of them, just at least one of them. So the alternative is at least one is off. Now what you're going to tell me is, we got a big p-value last time with the randomizer, yes? Big p-value means that there was no reason to think that everything was fine. If we get a small p-value, there's a problem that might occur. But I'm getting ahead of ourselves here, yes? We're getting ahead of ourselves. Let's collect data first. Let's collect data. Let's see how many candies you guys all got. We might not get any further than this today because we're running short on time. And I don't mind. I don't mind. We'll play with the data on Tuesday. That's totally fine. Give you guys a nice long... My God, I should have shaved. Nice long Thanksgiving weekend. Sans homework. All right. Laura, would you mind killing the weights if that's okay?
You don't want it.
Thank you. So here, I've got this sheet going. I've had it going since 08. This is what we... I have this time. I can copy it over. I've got a little systematic data collection here that we can analyze each of our colors. What I need to do real quick is I need to reset it. Oh no. There we go. Reset it all. So here's the way we're going to collect some data. What's that? Oh God, we dropping candy?
No, he found one.
You forgot the counter. I added it now. Time is 9. Use Christmas terms. Whatever you are. So what I'm going to do, let me just go around the room. I'm going to count. I'm going to shout out that color. We'll do each color in turn, and I'm going to count out how many of each of that color. Raise your hand if you got that many of that color. So browns. Anybody get no browns at all? No browns. 1 brown. 2 browns. 3, 4, 5 browns. 6.
5 browns.
You got 5. So Jesse got 5. 6 browns.
Yeah, 6.
2, 3. Yeah, just raise your hands. I'll get them counted in here. 7 browns. 1, 2. 8 browns. 1, 2, 3. 9 browns. 2. 10 browns. 11 browns. 12. A couple there. 13. I love this data. It's one of my favorite data sets all term. 14. Anybody above 14? What you got?
15.
Josh got 15. Anybody else above 14? So let me just give you an idea of what's going on in this sheet, and this is another reason why Excel is so freaking awesome. Up here, there's a new command that some of you that use Excel probably know about, but if you don't, it's awesome. It's called sum product. So what I was doing, this is pretty slick, I was just asking you guys how many of you got, say, 15, 14, 13, and putting that number in this column. It then takes that number and multiplies it by the number directly next to it to give you the total number of M&Ms by those people, and then it adds all that up. So it takes the product first and then sums it. So up top here, you see there's 162 browns scattered throughout the class and in your tummies right now. Pretty slick, huh? Pretty cool, pretty cool. All right, let's move to oranges. We got everybody counted? Oranges, no oranges. 2. I skipped one. One orange. There we go. Jack had one.
No, I have 0.
You have 0. Okay, we got 1 0. Orange is 1 orange. 2, 3, 4. Very cool, Jack. 5, 6. There's 2 6s. 7. 1 7. 8. 1 2 3 8. 9. 2. 10. 11, 12, 13, 14, there's a 14 for vacation, 15, anybody higher than 15 with orange? What do you got, Kelsey? 16, what do you got here?
16.
2 16s, did I miss anybody else with 16? Jess, what you got? I got you.
Sorry, no, actually, I got 8.
You got 8, so let's slap you in here, change that to a 4. You guys don't write anything down right now. We'll copy this down on Tuesday. We'll pull this out of the sheet and give it to you again. So what I like doing about this is I'm also over here graphing the distribution of what we get from each color. What's cool about the brown one is it's arguably bell-shaped, yeah? Arguably. Even on a small data set. Orange is interesting. Jack, you had 0, which is cool. But this is why we don't test just one bag. Because you get too much random noise. By collecting them all together, we're getting a better indication of what's actually going on in the data set. But still arguably bell-shaped, I think. Let's go to blue. Anybody get no blues at all? 1 blue. 2, 3, 4, 5. Okay, what do you got, Josh?
4.
You got 4, Kelsey?
5.
4, so you got a 4 and I got a 5. Anybody else get 4 or 5? 6 blues. There's 2 there. 7 blues. 1, 2, 3. 8 blues. 1. 9 blues. 1, 2. 10 blues. There. 11, 12, 3 12s. Oh, no, wrong place. 3 12s. 13s. Yeah, 13, bag gash. 14. Anybody above 14 with blues? What do you got, Drew?
15.
15. Beautiful. There you are. And again, pretty much a bell curve. Interesting. Let's keep looking at the data. Let's go to green now. Anybody get no greens at all? 1 green. 2, 3, 4, 5. 6, 7, 8, 9, 10. We got a 10?
Yeah, I got
2 10s? All right, 2 10s. 11 greens. 12 greens. Whoa, 13. Bunch of 2s, this is cool. 14.
A lot of greens.
1, 2, a lot of greens, good. Which we then have to look up at our screen and see, should we have a lot of greens? We'll come back to that, Kaylee. Thank you for that question. Did I get 15s yet? 15s? Ashley? 16 greens? 17, 18, 19. Anybody above 19 greens? Chris, what do you got? 20. There we go. Beautiful. There's our green distribution right there. So what's cool about actually looking at the data this way too is we see that brown and orange are about the same-ish. Maybe orange is a little higher than brown and blue. Brown and blue are about the same. Green's the highest so far. But hopefully your eyes are darting back and forth between the numbers on our screen and what Mars told us we should have.
Well, yeah, look, brown and blue are the most different in percentages. But
Good, and we haven't even counted red and orange, or red and yellow yet. Thank you, Kaylee. Good. Getting skeptical over there, I hope, yes?
Yep.
Good. Let's keep getting skeptical. Yellow. Anybody? No yellows. 1 yellow. 2, 3, 4. We got 1 4. Good, thank you, Kelsey. 5 yellows. 2. 6 yellows. 7 yellows. 1, 2, 3, 4, 5. Excellent. 8 yellows. Oh, there was 1 more. So that's 6. Not a problem. Got you, Dina. 8 yellows. No, oh, we got 1 of those. 9 yellows. 10 yellows. 11. 3 11s. 12s. 12 yellows. Anybody above 12 with yellow? What you got, Caleb? 14. All right. Anybody above 14? We good to go. One last data set, and we'll call it a day, is red. How many reds do we got? No reds whatsoever. We got no reds. Michael got 0. We're going to leave it as 1 there. How about, okay, there we go. We got one red. We got a few of you guys got 1. 3 of you got 1 red. 2 reds. 2 of you got 2. 3 reds. 2, 3, 4. 4 reds. 1, 2, 3, 4. 5 reds. We got 1 5. 6 reds. 7. 1 7. No, 2 7s. Thank you, Laura. Thank you. 8 reds. Anybody above 8 with red? That's our data right there, friends. So I'm gonna shrink it down so you can see what we're looking at. There's the graphs of what we saw. So according to, if I had to look at our graphs, I would say green is the highest percentage. It looks like orange, brown, maybe the same. Blue's a little under. Yellow is looking like it's probably over here on center. And red is the least. Does that sync up with what we see in these percentages?
Nope.
It doesn't appear to, does it? Now the question is, can we test it? Yes, the answer is yes, not in 4 minutes. So I'll save this data until Tuesday and we'll test it then, yes? And then we'll see if it's significantly off enough to believe that something's going on. Have a great Thanksgiving, you guys. Take care of yourselves, stay warm, stay healthy.
Thanks for the
And-
candy.
Oh, you got it, A little late breakfast, We'll analyze this next time. Make sure to bring it back. Yeah, make sure to bring it back. Don't listen to Chris. Enjoy them in your next class. Also, what you got, sir? Something happened and it cascaded down. Let me take a look. I have to do the math myself. With the Chris, but I'll take a look. I'll put a question mark, take a look when I get back. Bring it back on Tuesday for you. Math major, make me proud. It was wise enough to tell me to pull that. Good work for me the entire term.
A couple weeks ago when you asked if I was a nursing major.
Yes.
I almost said I was a math major, but I didn't.
I didn't think you were a nursing major. I don't know. Let's fix this, Jack. You want to? Yes, I do want to, because you can't run the test without it.
I don't have, I can't find the software.
We'll find it on yours then. I know where it is, I think. I think that cable fell out. I was packing today, Jack. We might not be able to.
That's all right.
But you know what?
I got a friend in.
I can get it to you. You have it on here. On Tuesday I can. The cable fell out of my bag when I was packing today. I remember watching it fall out. We'll get it to you on Tuesday. You won't get it between now and then. So for you, Danny, we have to go to your normal test screen, which is going to be yours, the apps. Catalyst, right? Test, it's under F6.
I have some kind of golf. something.
Chi-square golf. It's this guy right here, number 6.
Oh,
Right under 1 prop Z. The only trick is, and this
yeah,
is,
see,
it sucks.
Degrees of freedom.
What you have to do is I haven't written a program for this because this exists. How many categories are there? In this case, how many categories? So you put in 5.
Oh,
With the randomizer 10, you put it 9. You always put in 1 queue. That's it. And everything else is unit lists. And then you're done. That's it. I wish, I don't know why TI doesn't just make it count the degrees of freedom like I do, but they don't.
yeah.
That's it.
That's okay.
You're squared away.
It's really hard.
Guy squared away. Terrible stat joke. Sorry, Jesse, you had to hear that.